It's like a race and I'm winning.
No. Being ahead gives us the opportunity to retain the break. Yeah.
Not today, maybe tomorrow.
This will only take 5 minutes, don't do it.
Yeah, this will take 5 minutes. Exactly. Thank you, Ashling. Right, okay. So how you show events are independent. The formula we're going to come up with in a minute, right, okay, is not in the log table, so you need to learn it, okay? Right, and one of the questions that was on the sheet I gave you, one of them you needed to know this formula for it, so you wouldn't have been able to do it, okay? Right, but we did, before now, we did probability on A on condition of B.
Wait, are we finished with the Bernoulli, yeah?
Sorry? Yeah, we're finished Bernoulli, yeah. Right, so probability of A on condition of B. Does anyone remember the formula for that? Again, it's a formula you need to remember. A intersection B over the probability of B. Right? Okay? So, yeah. Yeah, they gave them out to you, yeah. Oh, yeah. Well, hopefully, listen, if Corona is still here by next June, you won't be doing any leaving cert, so you should be nice to me. Your life is in my hands. I love control. No. That's no, I can't answer that. I have.
But do you people have to be failed?
No. Well, look, I can't really answer that because it's like if there was someone that I thought would fail, I'd have to fail them. Do you know, in the interest of fairness, if someone's going to fail, you'd have to fail them. In the interest of fairness, because how can you pass them and then give someone else in the class who would have passed the same mark or something? Do you know, like, sorry? Yeah, like. And where was I? Right, okay. So that was the probably for conditional, right? Okay. So A on conditional B. But for independent events, girls, remember independent events is what happens in the first one doesn't affect what happens in the second one, right? So A on conditional B wouldn't matter at all, sure wouldn't? Right? For independent events, the probability of A on condition, what's the chance of A happening on condition that B happens? Doesn't matter, B is not going to affect it. So for independent, the probability of A on condition of B is the same as the probability of A. As in, it doesn't matter if it's A on condition of B. B is not going to affect A at all, right? So the probability of A happening on the condition that B happens is just the probability of A happening anyway, because B isn't affecting it because it's independent an event, right? So up there, instead of that, I can write probability of A is equal to the probability of A intersection B all over the probability of A. I'm now going to cross multiply, so that means the probability of A intersection B is equal to the probability of A, sorry, that's a B down there, probability of A multiplied by the probability of B. So if that is true, the events are independent, right? Because sometimes they don't tell you what the events are and you can't say whether they're independent or not, because they'll just say two events. Like if they said two events, the first event was throwing a dice, the second one was tossing a coin, you know they're independent, right? But sometimes they don't tell you what the events are. So for independent events, girls, this holds true. This formula holds true. This is an easy enough section because we're just going to be applying this formula. Okay, as I say though, girls, this is not in your log tables. This formula is one of the ones that is not in your log tables, so you need to remember it. So highlight it or do whatever you do with it. This one in the box. Probability of A intersection B equals the probability of A multiplied by, that's multiplied by probability of B.
Is that a B under?
Yeah, that's a B, sorry. So, is that okay? So this is the formula. So if they say prove these events are independent, you see does this work, okay? So my examples are going to be ones from the book, as in, my first example is page 70, no, page 200, can I take this away? Going? Gone? Right, so example 1 is page 214. Question 1. So basically, they gave me a Venn diagram. They tell me they don't tell me what A is, but there's 8 here, there's 4 here, this is B, there's a 6 here, and there's 12 on the outside. Okay? It says, what's the probability of A? So part 1 asks me to find the probability of A. So, how many is in A? 12 out of a total of 30, I think. So the probability of A is 12 over 30. We might as well cancel that down. That's 2 over 5. Okay? Is that right? Part 2 of that question asked me for the probability of B.
What's the number in the B section?
Sorry, what's the number?
The 6.
6, 4, 8, 4, 6, 12. Sorry. It's a perfect 6 in my book, but maybe not in yours. Right. Yeah, sorry. I think this is, so it should be like, yeah. Right, probability of B, so there's 10 in B, out of a total of 30, which cancels down to 1/3. Okay? And then they asked me, part 3, they asked me for the probability of A intersection B. So how many is in A intersection B? 4 out of a possible 30, which cancels down to 2 over 15. And then the final part is the new bit. Are A and B independent? It'll probably just be the Christmas test, sure. I don't want to be giving you a test on Friday, and can I get back to you on that, just to be sure? I'll do what the other class are doing, okay? But I'd be thinking no, because it's too near your Christmas test. Yeah. But I will confirm. Are A and B independent? So remember, if A and B are independent, that means the probability of A intersection B would be equal to the probability of A multiplied by the probability of B. Okay, so if they're if they're independent, this will hold true. So A intersection B is 2 over 15. Right, you just calculated it. Probability of A is 2 over 5. And then multiplied by probability B is 1/3. So when you multiply those, you'll get 2 15s equals 2 15s. So that's true, isn't it? So therefore A and B are independent. So you'd write down A and B are independent underneath. I've no rule. Just A and B are independent. Right, okay, example 2. Yeah.
So they are independent.
They are independent. So you would write A and B are independent, because the question is, are they independent? Right? Yes, they are. Okay? I take this away. Right, example 2. So, right, example 2 is page 215, question 11. Just 2. This is it. Right, on question 11, it says the probability of A is 0.2. It tells me the probability of B equals 0.15. They tell me A and B are independent. So they tell me they are independent. And then they ask me to find the probability of A intersection B. They ask me to find the probability of A on condition of B. And they ask me to find the probability of A union B. Right, so they're telling me they are independent. Right, so if they're independent, this formula holds true, that A intersection B is equal to the probability of A multiplied by the probability of B. So I know that's definitely true, that equation, that formula, because they told me they are independent. So that means the probability of A intersection B, they've told me A is 0.2, and they told me B is 0.15, and when you multiply those, someone might give me the answer of 0.2 multiplied by 0.03, is it? Okay, is that alright? Now, for the next ones, right, that's part 1. Part 2 is the probability of A on condition of B. So that's the formula for that, is the probability of A intersection B over the probability of B. That's a formula for conditional probability. We did that at the start of the other probability chapter. So that would be 0.03 over the probability of B is 0.15. Right, so that would be 0.2. Observation. Probability of A on condition of B is the same as what? Probability of A, right? So the A on condition of B, but we know they're in. We could have said that, because A on condition of B, B does not affect A at all. So A on condition of B doesn't matter. It's just A, the probability of A, because they're independent events. Okay. So we didn't have to use the formula there. We could have just said, oh, they're independent, it doesn't affect it. Right? For part 3 then, I'm going to do a Venn diagram, right? Because I just need to see what's what. Okay? So this is A, this is B, right? This is this is 0.03. Now, all of A was 0.2. So the whole lot of A is 0.2. So what would this one be? 0.17. Agreed? And all of B is 0.15. So this would be 0.12. Agreed? Okay, so they told me all of A was 0.2, so I take away 0.03 and I get 0.17. They told me all of B was 0.15, so I take away 0.03 and I get this. So then to get the probability of A union B, it's equal to 0.17, add 0.03, add 0.12, and that would be 0.32. Okay, is that right? I had that wrong. No, I don't. I have it right. Are we okay? Okay, so that's the end of my teaching for today. You'd be glad to hear. So we're going to do page 214 to 215, and you're going to do 2 to 10.